Okay, so here we are. Some of the problems looked at in section 7.3 in class. Again, this doesn't cover everything, but it covers a decent part of it. So we're supposed to prove if these two triangles are similar or not on 2 and on 4. Now, we had two methods of doing that in class. We had side, side, side. Sorry, we had three methods. We had angle, angle, where we had two pairs of congruent angles. Side, 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 we have all pairs of sides, and then side, angle, side. So looking at number 2, we have a couple pairs of sides and an angle they marked, which would lead us to think of side, angle, side. And if you look at the side lengths, 3 to 6 is 1/2, 4 to 10 is not. Okay. However, this is a right triangle. So is this. So the book's being sneaky here because if you tried to do side, angle, side, it wouldn't match up. But if you do the Pythagorean theorem, BC has a side length of 5, EF has a side length of 8. Now I actually have all three sides, which means I can compare 3 to 6 because that's the smallest, 1/2. 4 to 8, that's the next smallest, 1/2. And 5 to 10, all 1/2. So number 2 is yes, they are similar by side, 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 which is kind of tricky again because it looks like it should be a side, angle, side one. And then it'd be like triangle, I don't know, we'll say ABC. The right angle here is F. From A to B is F to D, and then E. So that's a tricky one. Number 4, we just match them up. We can just straight up match up smallest to smallest. So the smallest side here is 4. It matches to the 10. Smallest side here is 6. It matches to the 15. Biggest side is 8. Matches to the 20. So we're looking at side, side, side here to see if it works out. So we'll just set up the proportions. 4 to 10. 2 to 5. 6 to 15. Divide them both by 3. 2 to 5. And this was 8. I know it's kind of blurry now, but it's 8 to 20. Divide them both by 4. 2 to 5. So this guy is actually, again, this one's similar as well. So yes. Also by side, side, side. And then I'll just pick, I don't know, LKJ. Triangle, let's see, L corresponds to R. K corresponds to Q. And J corresponds to S. Okay. Now we did 1 and 3 as well, but those are odds. So if you want extra problems, you could just look in the book. All right, number 18. 18 is tricky. 18 is a tricky problem because you have to pay attention to the fact that that's a right angle. And your actual similar triangles are triangle WZU and triangle triangle YWU. How do I know that? Angle, angle. They both have Y and W congruent. Well, ZWU and angle Y, and they both have right angles. So if I redraw this guy, if I could think of like picking him up and turning him, he would actually orient like this. Right angle here, W be the single mark. Now he's lined up with this purple guy. Okay, U is still the right angle, Z is up here. And now this guy is x plus 6. This guy here is the hypotenuse. He's 3x minus 6. Okay, so now we get to have the fun of trying to say, okay, well, I can see 3x minus 6 corresponds to 40. Hypotenuse, hypotenuse. X plus 6 doesn't correspond to anything. I don't know this side. So here's the second tricky part about this one. I have to find the missing side length here doing the Pythagorean theorem. Okay. So I have to do x squared plus 32 squared plus 40 squared. Now I'm going to cheat. because there's a trick I know, but you would do the Pythagorean theorem. We did it in class. This side here actually ends up being 24. Sorry, 5 times 8, 4 times 8, yeah, 24. So now 24 and x plus 6 correspond. 40 and 3x minus 6 correspond. So we set up our proportion. 24 to x plus 6 equals 40 over 3x minus 6. And again, this is a hard question. It really is. This is the book stepping up the difficulty here, which is why we're doing this kind of this backwards way of doing it in class, instead of you doing it on your home alone. Now at this point, I got to just cross multiply. So it's 40 times x plus 6 equals 24 times 3x minus 6. So I get 40x plus 240 equals 72x minus 24 times 6 is 120, 144. Okay. Add 144, subtract 240. That ends up giving us 384 equals 32x. Divide by 32. What is that? 10. That's 12. So x is 12. Okay. And now I can find WZ by plugging in 12 for x here. So WZ equals 3 times 12 minus 6. So 36 minus 6. WZ is 30. And then ZU, or UZ, which is just 12 plus 6, $18. Okay. So yeah, that was a tricky one. That's a rough one. All right. 7.3. Gosh, I have a couple more. This will be a longer video than usual. 7.3. A cell phone tower casts a 100-foot shadow. Okay. At the same time, a 4-foot 6-inch post near the tower casts a shadow of 3 feet 4 inches. Find the height of the tower. So here's what we have set up. Cell phone tower casts a 100-foot shadow. So here's my cell phone tower. Has a 100-foot shadow, creating a right triangle. Okay. At the same time, a 4-foot 6-inch post. Okay, so 4-foot 6-inch post has a shadow that is 3 feet 4 inches. Now, one of the things we have talked about in class is this actually creates two similar triangles. We have the tower height to the height of the post, tower shadow to the shadow of the post. So we can set up that proportion. Now, what makes this one so difficult, though, is that this is feet and inches, feet and inches. This is just feet. You could convert all of them to inches and then reduce it back to feet, because we're going to want to know the tower in feet. We're not going to want to find it in inches. The actual other thing you could do is say, oh, well, 4 foot 6 inches. Well, 6 inches is half a foot. So this is 4.5 feet. Four inches, well, 4 inches out of 12 inches is 1/3. So this is 3 1/3 feet. There we go. 4.5 feet, 3 1/3 feet. So tower, I don't know, we'll call it X. We're looking for a height. So X to 4.5 equals shadow to shadow, so 100 to 3 1/3. Cross multiply. 4.5 times 100 is 450. And this ends up being 3.5x, which I'm going to make that 10/3 x, because that's what that really is. And then I'll multiply both sides by 3/10. That becomes 45. 3 times 45 is 120, so it's 135 feet then. So the cell phone tower is 135 feet tall. And then last one for this section. Okay. Talking about our good old hypsometer. Okay. This is a weird tool that it creates actually some similar triangles for us. So we have, okay, Bartolo and a hypsometer, and we talked about this class. You're not going to see this on a test or anything like that, but I just wanted to give you kind of a practical, application. Number 24. So Bartolo and his hypsometer can be used to estimate the height of a tree. He looks at the straw at the top of the tree and obtains the readings given. Find the height of the tree. Well, here's what we have to kind of piece together. What it is actually, it's a string that hangs straight down, and when you make it vertical to the ground, it's vertical here. Okay. And then what you do is you label it along a card, and what ends up happening is that height and that height create a right triangle that's similar to this right triangle. So we're going to set up some similar triangles. Now if you're wondering how in the world does that work, well, here's the real trick to it. This angle here is congruent to this angle. Okay? Because these guys are actually parallel, which means then that this is the angle up here, this is the angle down here, this angle is congruent to this angle, and here's a right angle. So the 10 is opposite this angle, meaning the 15 is opposite this angle. So the 10 and the 15 correspond, meaning the leftover portion, which is the 6, has to correspond to the x side we don't know. So 10 over 15 equals 6 over x. Okay. And we can reduce this to 2/3. Gives me 2x equals 18 divided by 2. X equals 9 meters. Now if you were to stop there, you'd be wrong. That's not the height of the tree. That's just this height right here, 9 meters here. The actual height of the tree is 9 meters plus the 1.75 meters that is Bartolo. So the tree is 9 plus 1.75, so 10.75 meters.